So here the thickness at the center of the plano convex lens is 3 millimeter. So you have a plano convex lens. So here the thickness is given as 3 millimeter. Okay, and the diameter is given as 6 centimeter. So here we will feel the diameter is given as 2 centimeter. So the radius of curvature is 3 centimeter. If you substitute this, you will not get any of the answer in this, because here you have to think in another perspective. Here this is a lens. If you turn this lens, okay, so if I turn this lens, this part we have, this is cut from a sphere. I have a sphere. Imagine this as a sphere, not as a circle. If I cut it here like this, here you will not have a flat surface. If you cut it and then turn it back, you will have one circle. In back of the circle you will be having this shape. So here this radius, this diameter is given as 6 centimeter. So here this distance is given as 6 centimeter. This you have to imagine. Now this distance is 6 centimeter. Now let me write it here. Okay, so 6 means if I divided exactly half, this will be what, 3 centimeter. Down it will be 3 centimeter. Now if you finish this sphere, not circle, it is sphere, it will have a center here. This will be the radius is unknown. Okay, don't take it as known, it is unknown. And here this distance will be what, I know this is 3 millimeter, so this will be r minus 3 millimeter. Okay, so here if we are using centimeter as the unit, so this is r minus 0.3. Okay, this is what we have now. Now if the speed of the light in the material is 2 into 10 to the power 8, so we know the refractive index is nothing but c by v. Your refractive index would be what, 3 into 10 to the power 8 by 2 into 10 to the power 8. So the refractive index comes out to be 3 by 2 or 1.5. So this is the refractive index of this lens. Now what is the focal length they are asking. So what is the focal length formula? Your focal length is nothing but r by n minus 1. So how this formula comes? It comes from your lens maker formula. Okay, so n to 1 minus 1. So here 1 by r minus 1 by r2. So radius of curvature of the first surface here is infinity, minus 1 by here radius of curvature of the second surface. If you put it as r, left hand side sign convention will be negative, so minus r. So you will get f is equal to r by n minus 1. This is what focal length formula. So now this r is unknown. Okay, here this r is unknown, but to find that r only they have given the detail of this 3 and 3, so we can make use of it. So for deriving that we can use some symbols. So here let me make this as x, and let me make this as t. And here you can see I have one triangle. Okay, I have one triangle. In this triangle, if I apply Pythagoras theorem, I'll get r square, which is equal to x square plus r minus t whole square. Okay, so now what I'll get, r square, which is equal to x square plus r square plus t square minus 2rt. This is what I'll get. So if it gets cancelled, and here you can see I have t square. T itself is very small. If you square that, it will become very small. So here this can be eliminated. So I can say 2rt is nothing but x square. Now the radius will becomes x square by 2t. This is what the radius. Okay, so now we can apply in this formula. So f, so f is nothing but r is what, x square. I have x square here, let me write it in format, x square by 2t into n minus 1. So I know n is 1.5. If you subtract it, you will get 0.5. Let me make it as 1 by 2. So 2 and 2 will get cancelled. So you will get x square by t. So x is what, 3 centimeters, correct? So 3 into 3 centimeter, thickness is what, 3 millimeter, which is 0.3 centimeter. So here if you do this, you will get 9 by 0.3. Okay, this is nothing but 3 by 0.1, which is 30. So 30 centimeter is the answer. So option C.